you will attend the classes, but the time is very short, as we have instructed that to complete the lab within the February month, but you are not attending these classes. We have almost 13, 12 or 13 programs. Okay, so in a single day it is not possible to show all the programs, but we need at least 3 or 4 classes, at least 3 or 4 classes, but we don't have enough time. So you are not attending these classes, so it is quite difficult for me also to complete the lab session. In the last class only Devajit was there, so how can I show the lab programming to only one student? So what I have decided ki, I'll provide you a link where you will give your feedback of the syllabus to the entire syllabus that Surya sir has already completed. If you have any doubts, then you can post your doubts on the particular topic, the topic name, mention the topic name there, and I will discuss based on the topics. Okay, and rather than I'll just take some days of some classes to discuss the labs. Okay,
Okay,
mainly I
sir.
will focus on the lab from the next week, as in this week only Thursday is there, Wednesday is college closed, so I'll get one lab in this week. From the next week you have the CF4 exam also, so you have to cooperate me, and just I'll provide you a extra date for the lab sessions. Okay,
Okay, sir.
so please try to attend those classes, lab classes, so that I can complete your lab syllabus also. And please provide your feedback through the Google form. I'll provide the link to your group. I have joined your group last week. Devajit has invited me to join the group. I'll provide a Google form link there, and please provide your feedback that you have any doubts regarding these classes that I have taken, and the previous classes that Surya sir had taken. These classes, if you have any doubts and anything, you can post there in the Google form. You can give your feedback.
Okay, sir.
Then I can discuss these topics. And the most important thing that is, uh, I'll provide you some assignments in ERP section. Please check your ERP regularly. I'll post it in within 1 or 2 days. Okay, some assignments will be there. That will be your suggestion also for CA4 and the semester. Okay, so
Okay, sir.
if you solve these assignments and give, make it prepared, then it will be good for your semester also. Okay, so without wasting time, I'm starting today's class. As so far we have seen some of the data link layer protocols. Uh, was bit oriented and byte oriented protocol. What is bit oriented and byte oriented protocol? And in bit oriented protocol we have seen the HDLC protocol, and some approaches were there, what is bit stuffing, etc., etc. We have discussed these things, but I don't think most of you attended those classes. Still I'm moving forward. Okay, if you have any problems regarding this class, then you can ask me after I've complete the session. Okay, so I'm sharing my screen as I'm in home. I'm unable to take it in Blackboard, take this class in Blackboard. So I'm sharing my screen using PPT. I'll start today's class. Is that visible? Is that visible?
Yes, sir.
Okay. All right. So basically that bit oriented protocol. In bit oriented protocol, what we have seen, we seen that uh, the transmission between two clients, like one is sender, another one is receiver. And whenever sender is sending data to the receiver, this data link layer, what the data link layer does is, data link layer have some protocols to form a frame. As data link layer has a sub layer that is called mac layer. This mac layer is responsible for creating some frames, right? These frames will be created in data link layer part, but the data is coming by converting in a conversion way, like application layer is responsible for that to obtain that data from the user. Then it is converted to multiple forms. In network layer it is converted to packets. In data link layer it is these packets are converted to the frames. And this frames some MAC addresses, right? And some header and the trailer part is there. And this header and trailer part, and with this are helping display a form. So this way we have multiple ways to create a form. Bit-oriented approach, we have SDLC protocol. Bit-oriented means we will deal with the bits, not the bytes. Means we will deal with just 0 and 1, 0 and 1. Okay. SDLC protocol, what we have seen that in SDLC protocol, this is base formation of SDLC protocol, where we have a starting sequence and we have an ending sequence. As we know, we need header, trailer to create a from to create a frame. Uh, this flag is denoted as starting sequence, and this one is the ending sequence. Okay, I got disconnected. What I was saying that we have seen the HDLC protocol. In HDLC protocol, this is the formation of the HDLC protocol. In HDLC, we have the header sequence, or the starting sequence and the ending sequence. Okay, this flag denotes the starting sequence and this flag denotes the ending sequence in HDLC. Okay, uh, now in HDLC, the starting and the ending sequence both are of 8-bit, and these 8 bits are constant. We can identify easily by seeing these bits, uh, 0 6 6 consecutive 1 and 0. This is the start for starting sequence, and 0 6 consecutive 1 and 0, this is for ending sequence. These bits are constant in HDLC model, and these bits separates a frame from another frame. Whenever we'll see that these beats are coming, then we'll identify it as the starting sequence. And when we see the second same sequence of beats, then we'll identify it as the ending sequence. The receiver, not we, the receiver will identify it as a frame. And then the second part of the HDLC model, that is the header part. In header part, in header part we have in header part this is the header part. Okay, this is the header part. In header part we have address and the control field. That is why header part is of 16-bit. 8-bit is for address part and 8-bit is for control part. What does this address part hold? Address part hold the IP addresses, the MAC addresses of the destination computer along with the source computer. And this control field controls the flow of the data. I've said that why we need the control flow. We need the control flow because whenever sender is sending some data to the receiver, sender have to adjust the data speed so that the receiver is capable of receiving that speed of data. Okay, so this address and the control field, this is called the header field. This is called the header field. And then it comes the payload. Payload means the body part. Means here we will have the data. The actual data will be stored in the payload or the body part. Okay, we don't have any sizes for that. This can be 16 or more than that. 16 bit or more than that. Okay, so after that the FCS, that means we need some error control protocols, error control algorithms. For that we'll have the CRC, cyclic redundancy check. This error checking algorithm will be implemented there. Okay, this will store this will hold some bytes, some bits there, that is of 16 bit. Okay, this algorithm holds in stores in 16 bit. It takes the 16 bits. Okay, after that the ending sequence will be there. Ending sequence and the starting sequence are of same bit sequence. Okay, this was in HDLC, a small recapture of HDLC. Okay, now um, what I have discussed in last class, that bit stuffing. What is bit stuffing? If this flag sequence or this starting sequence is appearing in the body part or the payload part, suppose a data consisting contains of this 6 consecutive 1 and 0, that is in data part, then what receiver will get? Receiver will get a header or the starting sequence and the ending sequence, which is in the data part, but it is not actually the ending sequence. It is a part of the data. So that, and there will be an error. Okay, it is called the framing error. To reduce this framing error, to optimize from this data from this framing error, what we will do, we will just add one extra bit after 5 consecutive 1. So after 5 consecutive 1, we will add here a 0. Okay, to optimize this error, we will add a 0. When receiver gets the packet, this frame, uh, receiver will remove this 0 and get the original data from the packet, from the frame. Okay, this is called the bit stuffing. In bit oriented approach, we'll see the bit stuffing. In byte oriented approach, we'll see the byte stuffing or the character stuffing. Now coming to the next protocol. Okay, the next protocol is bisync protocol. It is not so much important, but we'll see what is byte stuffing or bisync protocol. That is a bisynchronization communication protocol. Okay, the term bisync, that means two synchronization will be there. Two synchronization panel will be there in the communication. So you can see that two synchronization part is there. One is of 8 bit, another is of 8 bit. Okay, two synchronization part is there in the formation of bisync protocol. What bisync protocol do? It is a basic byte oriented approach. Okay, this byte oriented approach means byte oriented or character oriented approach means we will deal with 0 and 1, but not a single 0 and 1. Okay, 8 bit means 1 byte, right? We'll deal with the bytes. We'll deal with the bytes means 8 bit. We'll deal with every time we will deal with 8 bits. Okay, so synchronization for bisynchronization protocol, we'll have two sync part. Then we'll have a start of the header part. Okay, the start of the header part, um, will identify the header, and it's the starting of the header, which will hold the addresses and the control field and their protocols. Which protocols are there? It will hold that information in start of the header. Okay, after this header part we'll have a start of the text. This is very important for bisynchronization protocol, because whenever we are starting with the body part, we have to create a boundary on it. In other protocols we have the header and the trailer part, but in bisynchronization protocol we don't have header and trailer part, but we have two synchronization part. After that, a header part which will hold the address and the control field, then the body part. And this body part will be surrounded by start text and end text. STX means start of the text and ATX means end of the text. This will create a boundary to the body. Okay, so the start of the text is of 8 bit and the end of the text is also of 8 bits. After that, we'll have a error checking algorithm that is of 16 bit. Now, the start of the text and the end of the text will hold a same pattern of bytes. Now, suppose if the body holds a pattern that is same as start of the text or end of the text, means what I'm saying that, suppose the start of the text is 1 1 1. Suppose it is not possible 1 1 1 only, at least it would have 8 bits to form a byte. Okay, so this 1 1 1 is the sequence. For time being I'm giving you an example, and the end of text is also 1 1 1. Okay, now this body part, if this body part holds a data which consists of three consecutive 1, okay, three consecutive 1, then what will happen? The receiver will identify the start of the text, that you will get that this receiver will get that, it will get that the now the data part is being started. Now it will try to identify the data part. After getting the start of the text, the rest of the part it will get at as the data part, but it is getting another 1 1 1 in the data part, then it will consider it as the end of the text. Okay, it will consider it as the end of the text. What is happening here? A data loss will be there, a framing error will be there. Okay, it is creating some framing error. So in bit oriented approach we have seen the bit stuffing, but in byte oriented approach we will see the byte stuffing or character stuffing. But byte stuffing, it is not possible to replace one bit or adding some extra bit to the sequence. It is not possible. For byte oriented approach we have to add a sequence or one extra byte, right? As it is byte oriented approach, so we have to add an extra byte in the data part if this framing error occurs. Okay, after adding this extra byte, whenever it comes to the receiver side, receiver will omit this extra byte and it will get the original data. Is that clear? Is that clear?
Yes, sir.
Okay. After getting the original data, this term is this term is called as the byte stuffing or character stuffing. Okay. Now the most important protocol. One more thing is that this bisynchronization communication protocol is also known as BSC protocol. Okay, these BSC protocol are basically used to describe various types of data packets that is given below. See that: inquiry, acknowledgement, negative acknowledgement, and end of transmission. These packets we can perform these types of works or these various types of data packets in the using this bisynchronization protocol. Suppose we are giving we are transmitting our data. This is our inquiry. This data is being transmitted to the receiver, and receiver is giving some acknowledgement to the sender. These types of tasks we can perform using this bisync, but it is not being in used hugely used protocol. The hugely used protocol used protocol is PPP protocol, that is point to point protocol. It is very important for your exam also. You may find some question from PPP or some short notes, it is being asked that write some short note about PPP. So PPP is very important, as this PPP protocol is in normal nowadays we are using this PPP protocol in everywhere, like in your WAN connection, widely area network, the what the we have seen that LAN ports are there. This LAN where or are basically who performs this PPP protocol. This is consist of this PPP protocol: phone line, trunk line. You can see the examples there, cellular telephone, everything is now following this PPP protocol. This PPP stands for point to point protocol. Okay, it is a important protocol of data link layer. Basically this protocol, PPP protocol, uh, um, commonly run over the WAN or widely area network, and it follows the routers. Means one router to another router. We are making some connection between one router to another router. Then we will follow this PPP model. Okay. Uh, Widely used in broadband connection, also broadband communication. Okay. As this protocol can handle lots heavy loads and high speeds of data. Okay, this high speeds of data and heavy load, you can transfer these types of data, high speed data or huge data, heavy load of data using this PPP protocol. Okay. um, Now we'll see that what is the formation of this PPP protocol. So this is the formation of PPP protocol. But look at the formation. It is as usual as HDLC model, as same as HDLC. Okay, what we have seen in HDLC, this is the starting sequence, this is the ending sequence, and these two are noted as header part. But in PPP model, we'll just uh, make it go as flag, address, control, protocol, data pairing, or error control, and again the ending flag. Okay, this is the formation of the PPP model. This flag, this pattern of flag is same as the HDLC model. Okay, it is 0, 6 consecutive one, and again another 0. So this starting and the ending flag will be same, 0, 6 consecutive one, and another 0 will be there. Okay. Now after that, this address part, in this address part, the address of the destination computer along with the source computer, the MAC address will be stored there, and the control part will again hold the control flow informations. Okay, after that some protocols will be there. So this protocol part, what this protocol part do is it is of size of 1 or 2 byte, that means of 8 or 16 bits. Okay, everything is flag and the address and the control field are of 8 bit, but this protocol can be of 8 bit or to 16 bits. Okay, so this protocol field is uh, holds some information about the data field. Means which type of data is there in the data part. Means this is the data field, this is the data field or the payload field. Which type of information is there? This information will be stored into the protocol part. Okay, so what type of data is there, the types of data and some information about the data will be stored in the protocol part. Now comes to the coming to the data part or the payload part, and this payload part will hold, definitely it will hold the main data. It can be of text data or any multimedia data. After that, some error algorithms will be there. In this case, we'll uh, use the checksum for error control. Okay, what we have seen in HDLC and Bisync protocol, that we are using the CRC, that means the cyclic redundancy check protocol. But here in our PPP protocol, we'll use the checksum. Okay, let me tell you one thing, that this CRC, that means cyclic redundancy check, or these checksums, these protocols I will discuss in the further classes. But for time being, you just know that you just keep it in mind that we'll use the checksum for the PPP protocol, and after that the ending flag will be there, and this ending flag will hold this sequence. Okay, now one more thing, important thing is there. One byte information, which suppose in address field, it is holding one byte information, right? In case of broadcasting, the address bar will follow this sequence. Okay, this is the constant sequence for the address part when it is turning to the communication, which is of broadcast type communication. Okay, in broadcast type communication, this address field will hold this sequence of bytes. Okay, in control field, this byte sequence, it is also the constant, that is of two ones and six consecutive zeros. So these two fields are constant, and the flag starting and the ending of the flag, it is also the same. Okay, so the basic difference of HDLC and the PPP model is that when in HDLC, we are using this CRC protocol for error checking, but in uh, PPP we are using the checksum. But the another difference is the error control and the address field. Where in HDLC, the control and the address field, we know that these two fields are considered as one field, that is header. Okay, in PPP, this address field is constant for broadcasting, and the control field is also constant. Okay, so these are the basic differences from between the HDLC and the PPP model. Okay, is that clear? Is that clear?
Yes, sir.
Okay, now as this PPP model is also a byte oriented approach, so if any flag is means this sequence, know it as flag sequence, this sequence is being repeated in data part, then the framing error will occur, and for that framing error, again we'll have to perform a stuffing. As it is the byte oriented approach, we'll perform a byte stuffing in PPP model. Okay, on the next class, uh, so far we have seen the some protocols, bit and byte oriented approach in a data link layer. From the next class, we will focus on the error part. Okay, error detection. We will see the types of error and some protocols regarding these errors, like CRC, checksum. Okay, these protocols are there. We'll see this protocol one by one. VRC, logical redundancy check, LRC. These protocols are there. we'll see it one by one. Okay. And what I have said that please do attend the lab classes Thursday. Okay, I will try to cover two or three experiment in Thursday. Okay, so we have to complete the lab classes within this February. So please do cooperate with me and feel free to ask me questions. If you have any doubts in any topic, you can ask me, or uh, I'll provide you the feedback link. You can post it there. Okay. Then after that, I will provide you some assignments, and there will be a suggestion for your exam CA4 and semester. Okay. So this is for now. Thank you.
Thank you, sir.
Hmm.